Here we have to find the derivative of the function cos ax by using first principle. So here in the solution we will write the function f of x is equal to cos ax. Take it as 1. Now we will write f of x plus h, means in place of x we will write x plus h. So this function becomes cos a, it is x plus h. So f of x plus h becomes, take a inside the bracket, we get cos ax plus ah. Take it as 2. Now we have the general formula f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. This is our general formula. So in place of f of x plus h, we will substitute cos ax plus ah. Minus f of x means it is cos ax divided by h. So here the function becomes f dash of x, first order derivative, is equal to limit h tends to 0 cos, it is ax plus ax plus minus cos ax whole divided by h. Now this is of the form cos c minus cos d. Suppose we have the general formula. This is cos c minus cos d. This is equal to minus 2 times sin c plus d by 2 into sin c minus d by 2. So suppose our c is equal to ax plus h. Here I am writing c is equal to ax plus ah and d is equal to ax. We will substitute in the above line, we get f dash of x is equal to limit h tends to 0 minus 2 sin c plus d means it is ax plus ah. Okay, here on the next page I will write it because the place is not sufficient. Here we get f dash of x is equal to limit h tends to 0 minus 2 sin c minus d means here we will write 2 sin c means ax plus ah plus d means it is ax by 2 into sin c minus d means it is sin c means ax plus ah minus d means it is ax divided by 2 whole divided by h. Now here it is plus ax minus ax. So we will cancel the first and last term. And this ax plus ax becomes 2 times ax. So here we will write f dash of x is equal to limit h tends to 0 minus 2 sin, this is 2ax plus ah by 2 into sin ah by 2 whole divided by h. Now we will take this minus 2 outside, means we will write before the limit h tends to 0. So this becomes f dash of x is equal to minus 2. Open the bracket. Here we will write limit h tends to 0. Now here we have two terms, so we will separate them. It becomes sin 2ax by 2 plus ah by 2. Now we can cancel this 2 from denominator and numerator into, here we have sin by 2. It is 2h by 2 whole divided by h. Now this becomes f dash of x is equal to minus 2 limit h tends to 0. This is sin ax plus ah by 2. Sin ax bracket, it comes here, sin ax plus ah by 2 into sin ah by 2 whole divided by h. Now we will separately apply limits on both for both the terms. Here we will write minus 2. This is limit h tends to 0 sin ax plus ah by 2 into limit h tends to 0. This is sin ah by 2 whole divided by this h I am writing here, whole divided by h. Now f dash of x is equal to minus 2. When we substitute the limit h is equal to 0, the second term becomes 0. First we will write sin ax plus 0 into, here we have limit limit x tends to 0 sin kx by x is equal to 1. We have x is equal to k. We have this formula, here I am writing. Limit x tends to 0 sin kx by x is equal to k, means the coefficient of x is k. Here the coefficient of h, means this limit is in terms of h, coefficient of h is a by 2. So the value of k becomes a by 2. When we apply this formula, here we get sin a by 2. No, it's only a by 2. A by 2. Now this becomes f dash of x is equal to minus 2 sin ax into a by 2. Cancel this 2 from numerator and denominator. So the required answer is f dash of x is equal to a I am writing here minus a sin ax. This is the required answer.